Hello and welcome to this video. Today you're going to learn how different forms of sensing technologies and GIS-supported spatial analysis can help you to discover the relationship between urban form and livability. As an example, I will use the phenomenon of the urban heat island and its influence on human health and well-being. In short, the urban heat island is the phenomenon that cities heat up faster during day than their rural surroundings and also cool down slower during the night. This map shows you the air temperature during a warm summer night over the west of the Netherlands, the so-called Randstad. You can see clearly that the cities are hotter than their surroundings because the air above them does not cool down during the night. But first, let us investigate which negative impacts the urban heat island has on our quality of life. The heating up of the cities is specifically relevant during heat waves, which are longer periods of high temperature, often accompanied with high levels of ozone concentration and smog in cities. You all experienced yourself that on a very hot day you're sweating, your concentration is reduced, and you are just less productive. In order to keep our offices and houses on a pleasant temperature, we need to cool them. This means we use more electricity. Our plants and gardens need more water. In short, we need more resources. The most crucial effect of the urban heat is though that more people, specifically elderly and people which are weak due to illness, die. In this chart, we overlaid the mean temperature with the ozone concentration and the numbers of deceased elderly during a heatwave in Rotterdam in July 2006. You can see clearly how the peaks coincide. You can measure the temperature difference between the city and its surroundings, but also between different places within a city at several levels and scales. You can measure the surface temperature in a city or the air temperature in the so-called canopy layer or in the atmospheric layer above the city. Very interesting is also to understand the temperature in houses, as most of the time we are actually indoors. And it's, of course, important if you want to investigate day or nighttime temperatures. The most common used technology to measure surface temperature is remote sensing. Remote sensing is the science of gathering data on an object or area from a considerable distance with the use of sensors like a radar or infrared photography to observe the Earth. The Landsat program is a joint initiative between the US Geological Survey and NASA, which since 1970 gathers routinely land imagery from space. The youngest satellite is Landsat 8 and is operational since February 2013. Satellite images are publicly available through the link provided in your lecture notes. Landsat 8 has two instruments, the operational land imager, which collects data in visible, near-infrared and short-wave infrared wavelengths, and the thermal infrared sensor, which measures heat emitted from the Earth's surface. Using a combination of these wavelengths allows us to make surface temperature maps like the one of Amsterdam you see here. You can really do it yourself. It's not rocket science. Well, it actually is, but there are several online tutorials that help you making these maps. You find a link to one of those in the lecture notes. To map and understand the air temperature or the indoor temperature, we use either thermometers in meteorological stations across the city, or we distribute thermometers within houses across the city that collect every 10 minutes a temperature measure. In the future, the many smart thermometers that are distributed with heating and cooling systems will collect this big data on a regular basis. Based on the measured indoor temperatures, we can model the temperature in houses over time, like in this animation of the temperature in houses across Rotterdam during a future heat wave shows. You first see the temperature during a regular night where the city still cools down, and now during a night in a heat wave where the city doesn't cool down. or you visualize temperatures in 3D, as this view over Rotterdam shows. So, by now we know where the city heats up, but two questions remain. First, why does a specific area in a city heat up? And second, where do most vulnerable people live? We answer both questions using a geographic information system, in short, a GIS, and spatial analysis. A geographic information system is a system designed to capture, store, manipulate, analyze, manage, and present all types of spatial or geographical data. Why as it heats up more in specific places than in others is related how the urban form of a place influences the energy surface balance. Simply put, areas with high amount of sealed concrete surfaces and high building densities heat up more, whereas areas with a lot of green and water are cooler because of evapotranspiration. Using a GIS, we map the hotspots of Amsterdam in red, which are areas with a high level of imperviousness, little green and water, and a low sky view factor. How vulnerable a specific person is depends on three aspects. The first, the condition of the individual person. Elderly and sick people are specifically vulnerable. Then, the building the person is living in. Can the house be cooled? Is it well insulated or not? Is sun shading available or not? And third, the neighborhood a person is living in. Do neighbors take care of each other? Are health and other social services available or not? Combining geographic data sets of these three aspects, we produce this vulnerability map of Amsterdam. The areas in black are those with the highest vulnerability, because many elderly people live in bad houses in relatively bad neighborhoods. With all this information, we have combined using different methods of data acquisition and combining them with the help of a GIS and the knowledge gained in this process, we can now decide which measures to take where. These measures include changes of urban form on the house and on the neighborhood level, but also changes of social and healthcare services. But this is another story for another video. Goodbye.